Today, in continuation with chapter Biomolecules, we shall be studying about fructose. Fructose is an important ketohexose. It means it has keto group at second carbon and it has 6 carbon atoms. It belongs to D series and it is levorotatory compound. Its molecular formula is C6H12O6. Next is the structure of fructose. It, it means that fructose exists in two cyclic forms which are obtained by the addition of OH at fifth carbon to the CO group. The ring thus formed is five-membered and is named as furanose with analogy to the compound furan. Furan is a five-membered cyclic compound with one oxygen and four carbon atoms. Cyclic structure of furanose, it is also known as, it is also cyclic structure of fructose. It is also known as Fischer structure. The two isomers or these alpha and the beta form of the fructofuranose differ in the arrangement of CH2OH and OH group around second carbon atom. Next is Howard structure. In the Howard structure of furanose, there are two anomeric forms. One is alpha D fructofuranose and another one is beta D fructofuranose. Here furan is a five-membered heterocyclic ring with oxygen atom and these two forms are two cyclic structures of furanose. What is the difference between two? If you will see the second carbon atom, the OH group on the second carbon atom is below the plane in case of alpha D fructofuranose, and in case of beta D fructofuranose, the OH group on the second carbon atom is above the plane. Next is disaccharides. We all have discussed about oligosaccharides and we know that oligosaccharides upon hydrolysis give 2 to 10 molecules of monosaccharides and they can be further classified as disaccharides, trisaccharides or tetrasaccharides depending on number of the monosaccharides produced after hydrolysis. The two monosaccharides units are joined by a special type of linkage which is known as the glycosidic linkage. The glycosidic linkage is also known as an oxide linkage which is formed by the loss of water molecules. Thus, the linkage between two monosaccharide unit through oxygen atom is known as glycosidic linkage. In disaccharides, if the reducing groups of monosaccharides, that is aldehyde or ketonic group, are bonded, then these are non-reducing sugar. And if these functional groups are free, then it is known as a reducing sugar. First disaccharide which we will be discussing is sucrose. Sucrose is also known as cane sugar. Its formula is C12H22O11 and when the hydrolysis of sucrose is carried out, it forms glucose and fructose. Sucrose on hydrolysis, it means give equimolar mixture of D-glucose and D-fructose. Two monosaccharide units are held together by a glycosidic linkage between C1 of alpha D-glucose and C2 of beta D-fructose. Non-reducing sugars as reducing group of glucose and fructose are involved in the glycosidic bond. Here I have shown the structure of sucrose. In the sucrose, the two monosaccharides units are held together by the glycosidic linkage between the C1 of alpha glucose and C2 of beta fructose. Since the reducing group of glucose and fructose are involved in the glycosidic linkage, so the sucrose is a non-reducing sugar. Now, why the sucrose is also known as invert sugar? Because the sucrose is dextrorotatory, but after hydrolysis, it forms dextrorotatory glucose and levorotatory fructose. Since the levorotation of fructose is more than the dextrorotation of glucose, the mixture is known as levorotatory. Thus, the hydrolysis of sucrose bring about a change in the sign of rotation from dextro to levo, and product is known as the invert sugar. Next is maltose. Maltose is another disaccharide. It is composed of two alpha D glucose units in which C1 of one glucose is linked to the C4 of another glucose unit. The free aldehyde group can be produced at C1 of second glucose in the solution, and thus it shows reducing property, so it is a reducing sugar. Next is lactose. Lactose is also known as milk sugar, and it is a disaccharide. It is found in milk. It is composed of beta D galactose and beta D glucose. The linkage is between C1 of galactose and C4 of glucose. Hence, it is also a reducing sugar. Polysaccharides. Polysaccharides contain a large number of monosaccharide units joined together by glycosidic linkage. These are most commonly used carbohydrate in the nature, and they mainly act as food structures or food storage materials.